Em português ou em inglês?
Oh, maybe English.
Both.
Maybe both.
Okay. Do you
So,
want me to say what I'm doing here?
yeah, what are you doing here? And who are you and
I'm
where are you from?
Letícia. I'm from São Paulo. I studied at USP, São Paulo. I'm a forest engineer and I'm doing my master here at the Central Amazon. And today I'm helping to collect some data about stomata here in plants. Conductance stomática.
Okay.
I'm working with some new equipment for me, at least, like leaf pormeter. And
Can you show the equipment?
Yes, it
Okay.
works like I put some leaves inside here,
Uh-huh.
and the equipment reads the stomatal conductance,
Yes.
and I take some notes about the time, the leaf temperature, and the stomatal conductance. And I was here at the tower since 5:30 o'clock today, and
Wow.
we are going to do this for all the day.
Wow. Very dedicated.
Yeah.
And what is stomatal conductance?
It's when we can measure here the flux, the carbon going into the stomata, into the leaves, and it's micromole per square meter per second.
The conductance.
The conductance, and we already had some interesting data here. In the beginning of the day, the mature leaves.
Mature leaves.
The mature leaves had higher stomatal conductance, and the new leaves have had lower values. But now they are growing, and the new ones are becoming closer of the. I don't know. We have to collect more.
Wow,
but,
that's interesting.
Yes, so interesting.
So maybe the young leaves are sleepy.
Yes, maybe.
And they wake up later.
Wake up later.
Oh,
It seems.
That's very interesting.
Yes, and I saw some difference from the top of the crown and where we are now. There, the values were all higher for young and mature leaves, and here, because of the light, maybe the values are a little
lower.
Yes.
So, like for example, you're in the bottom part or the middle part of the crown.
Yes.
And they're lower than up higher in the top part of the crown.
Yes, we can see some difference.
Well, what about the temperature?
The temperature is higher there too.
Ah, okay. Interesting.
Yes.
But what do you think will happen if it gets really hot, like in the afternoon?
I think that will be a limit for the stomatal conductance, and maybe the stomata start to close for like I don't know, 11 o'clock maybe, when the sun is so hot, maybe.
So you think it's possible that the stomatal conductance might be higher in the lower canopy than the top part because it's too hot.
Yes, maybe.
In the top part.
And here they still open, maybe, stomata. And there goes.
Pretty cool patterns already.
Yes, I'm liking.
That's great. And why is stomatal conductance important? Why do we care about stomatal conductance?
because it's totally related to the net primary productive in the forest.
Mm-hmm.
How much carbon this plant can get and assimilate, maybe.
Yeah. And what about water?
Water. Yeah, it's important too because when the stomata is open, plants losing water too.
Uh-huh. Yeah. Okay.
Okay.
And do you have any idea about seasonality of stomatal conductance if you measured in the dry season versus the wet season? What could be the pattern?
Maybe in the wet season they still open for a little more time. I don't know. And in the dry season, stomata closed early in the day to lose less water.
Interesting.
Less water.
Yeah.
I don't know.
Interesting. And why is a forest engineer measuring tree physiology?
Because we need to understand the plants in the scale of the cells, and maybe one day understand all the relations inside the forest, maybe.
And with the environment.
Yes. We had
Why do we need to know those relations as a forest engineer?
I can see relations with the climate change and the growth of the forests and this kind of things.
Yeah. And so, is this part of your master's project?
This work with pormeter?
Uh-huh.
Maybe, because I really like it.
Yeah. Because are there any other ways that the water and the gases can exchange with the tree, or only the stomata on the leaves?
No, I think there's other ways, like at the stems, maybe by the lenticels.
The lenticels. What's the
Yes.
lenticel?
It's an anatomical structure, and I think that the trees can exchange gases and water vapor with the atmosphere by this structure. I don't know.
But could you measure like the lenticellular conductance with something like this parameter?
No, I don't think this equipment can do this. Maybe.
Maybe you could adapt it.
Yes, maybe.
Modify it.
Yes.
Because do you think that the lenticels can open and close, or are they just fixed?
I don't think so. I think they are fixed, always open.
Always open.